Hello and welcome to this Python tutorial about making an object move on a screen or a window or a user interface. I made a bunch of classes. I put them all in this file. I have one other file where I have a time class and I import time and math. These are both modules. And then I just have this function called run. This is basically like the main function if you're familiar with C++. And this is where everything kind of starts. I have a global variable called game, and it is set to an instance of the game class. So in other words, game is an instance of the game class, which I have here. I'm not going to go into the details about what this actually does. And then I call this is a function here, and then I call the run function. I could have put game in a different location in this file, but I'm not going to move it at this point. Okay, so we go into the run function and we make a grid, but we don't draw the grid because I realize that when you continuously draw a grid, it looks glitchy on the screen. If anyone has a workaround for that, I'd be interested. Let me know in the comments. But I'm just going to make the grid so that I can get the square width and the square height, but I'm not actually drawing the grid on the screen. Next, I define a time object. This is an instance of the time class, which is over in this file here. This allows me to keep track of the current time and to keep track of differences in time in units of seconds, roughly. Then we have a Galilean object. I am interested in something in math called a Galilean transformation. So I actually made a function that computes this transformation and allows for updating a position based off of variables x for the x position, v for the velocity, and x prime for another x position. I'm not going to get into the details of a Galilean transformation right now, but just know that this function is what is allowing us to see the movement on the screen. Interestingly, actually, the properties, which are these, are updated. So, well, actually, the only property that's updated is x prime. So originally it's none, and then in the initializer, it's set to none. And then when I call this get x prime function, I guess I'm not updating the x prime property. I just realized it's only updated in this animated function, which is fine, but I'm calculating x prime separately from updating the x prime property. So I'm calling this function here. And this is interesting because then I can change the x prime position, and that essentially is what allows us to see movement because the position is changing. The x prime position is changing, and there is no updating of the other coordinates. The x is not changing, the velocity is not changing, the y coordinate is not changing. Remember, we're working in 2 dimensions, so I need to specify a y coordinate. And so the x prime is what's allowing us to see the movement, which you will see in a second once I finish explaining this code. So we define an x coordinate of 0. This is the initial x coordinate. Actually, it's maybe not a good idea to think of this as the initial x coordinate. This is the x coordinate. Because I'm thinking about this in terms of a Galilean transformation to be mathematically accurate. And of course, there are different ways to do this. I just think it's kind of neat to explore this new concept of Galilean transformation. I am definitely not updating the y values at all, and the velocity is -1. The units here are just one unit based off of the grid that's made. So I call that unit a square width, which is eventually set with this set square width function, where I call self.compute square width, which is done here, dividing the window width by the number of columns. Okay, moving on, we have our spatial dimension or spatial units. And I'm just calling it a unit. And then the velocity would be the number of spatial units or number of units per quote unquote second. The time units that I'm using are roughly seconds in our real world, or at least in the computer's world. Defining time is not an easy feat. Okay, now we get into this while loop, and this is a Boolean. Proceed is set to none originally, but then it's set to true until it's set to false by the user, where game proceed is set to false if the user clicks on the little X. So the way you determine whether the user clicks on the X or not is by cycling through the events in the game's events, where I have a function called get events, where I call a function from pygame, pygame.event.get. So there is actually a property of pygame called event, and it has a get method. Okay. Anyways, moving on, I explained what this code means. The game continues until the user presses the X, and then if the user hasn't pressed the X, we will animate based on the time object that was created and the Galilean object that was created. So let's go to this function. I just have a global function right now, and I pass those objects, and I call time object, update the current second. So figure out what the current second is based on that time class over there. Then I determine if more than at least 1 second has elapsed. If so, make the entire screen white, fill the entire screen with white. So basically erase everything. Then animate according to my Galilean.animate function that I briefly showed earlier. It's this function here. I have this extra space, but I'm updating the x prime function according to this Galilean transformation. I'm updating x prime property, sorry, according to this function here. And it depends on the time, of course. And then I make a mark, which is an instance of the mark class. The mark has a color. It has a X, well, it has a position that I set to whatever this X prime is. And I keep the Y position constant, and the 10, I believe, is the radius of the mark. Yeah. So I'm initializing the mark here, and then I plot it because in the mark class, I made a plot function that I can call. And this essentially draws a circle on the screen with the specified properties and scale factors, where the scale factors are based off of the grid that was made, but not actually drawn. So you can see that get square width being used to define a scale factor. All right, that covers the animate part of the Galilean class. And then the last part here is updating the previous second inside of this if statement so that the previous second isn't updated at every single iteration through this while loop, but only if one whole second has elapsed. We update the previous second and set that equal to the current second. But the current second is updated at every single iteration through the while loop, which happens very, very quickly or frequently. And then finally, once we exit the while loop because of this Boolean being set to false, the game ends. And that is the end of this run function. So I'll put some spaces here so you can see the differences between these three things. I'm calling the run function after instantiating the global game instance. And now I'm just going to show you what appears on the screen due to all of that code. And here we go. We have a purple dot moving every second, one grid unit, and then it goes off the screen. So maybe one of the things I'll do in the future is prevent that little dot from going off the screen, but that is how you can do an animation in Python. Of course, there are many ways to do it, but this is just one of those ways. And I hope you found this video helpful and useful. So thanks for watching.